All right, so we're going to simplify, multiply, and divide rational expressions. So let's first just start off and talk about what rational expressions are and a couple of the things that are involved with them. So an expression that is the ratio, as you can see over here on the right, of two polynomials. So we've got a numerator, we've got a denominator. It is rational because one of them divided by the other is like a ratio. So note the polynomial that you are dividing by cannot be 0. We cannot divide by 0, and we'll talk more about that in this next section. So it's just like a fraction, but with polynomials. So here's some examples. Got a couple of examples there for you to look at. Here's some non-examples. So this one is okay because the numerator is 1. And this one is okay because it could be written over 1. So you're not dividing by 0. But some non-examples as well would be anything that has a square root, because remember we're talking about rational. So the square root is irrational, which means we can't have any of those. We also cannot have, if we rewrote this, that would have a negative exponent, and we can't have any negative exponents. So that would be another no-no. So let's talk about why we can't divide by 0. So we know slope is rise over run. If we have something that's undefined, then that means we're trying to divide by nothing, which is no run, which is not possible there. So a ratio being undefined when the denominator is equal to 0. So let's take a look at some of these values that x cannot be, because that would end up being equal to 0. So down here, if we set that equal to 0, x cannot be negative 5. Here x cannot be 0, and we're just looking in the denominator spot. So set these equal to 0, and basically you're just solving, add 2 to both sides, so x cannot equal 2, and x cannot equal negative 3. So I'll give you a second to think about that last one. What can x not equal? What two things for that last one? Hopefully you're thinking x cannot equal 1, or x cannot equal negative 5. All right, so let's go ahead and talk about simplifying, how we can actually simplify some of these things. So we need to be careful because there's some big things that we can make mistakes with. We can only cancel out entire quantities. We can't just say, oh, there's a 5 and there's a 5 and they're above each other, so let's cancel them out. It really depends on how they're written. Multiplication is your friend. So these are all considered quantities that you could separate them with multiplication. And when there is that separation of multiplication or sets of parentheses, then we can go ahead and cancel out things that match up exactly. But if there's just like a 5 up here and a 5 down here, that's something that we cannot cancel because it's like these two are married and then we have a single and they can't split it up there. But here, these are just hanging out next to each other, but we can go ahead and simplify those. So here again, separate by multiplication. They're not in parentheses there or have addition, so we would just have 1 over 5. Here, this is an entire quantity of 5x plus 2 and a 5x plus 2. It does have a plus, but the whole thing is in parentheses, and this whole thing is in parentheses, and they match exactly. So we can go ahead and cancel that, and we write what's left. So a couple things on this last one that can cancel. The 5x on the top and the bottom. Again, 1 on the top, 1 on the bottom. They match up. They're exact. You can cancel them. Here, 5x plus 2, 5x plus 2 match up exactly. 1 on the top, 1 on the bottom. So we're left with 1 on the top and 2 on the bottom. Okay, so nothing matches on these, even though it may look like it. Again, this is addition, but these are two separate things. It has to be exact. So look at those non-examples and make sure you understand the difference. All right. So again, thinking about it with numbers. And this should be multiplication in order for it to. Yeah. So 5 over 5 could cancel. 4 over 4 could cancel. So you'd be left with 7 halves. But since that's addition there, we'd have to add them and then try and simplify with factors of them. So it would look a little bit different. All right, so let's go ahead and look at some that are already factored for us. And notice anything on the top that matches anything on the bottom exactly, can cross those off. We have a 4x over x minus 4. Now the other thing, think back, what can x not equal? And remember that this cannot equal 0. So what would make x equal 0 in the denominator spot? Yep, 4. So that's our final answer. We want to identify any x values that would make it undefined and simplify. So I want you to try these next two. Don't forget to figure out what x cannot equal, and then we'll check when you're ready. All right, so let's check. We can cancel off the x minus 1's there. So we're left with this. And we cannot have x equal negative 3 because that would give us 0. Over here, the only thing we can cross off is the x plus 7 on the top and the bottom, and so we have this left. And so that means we set this equal to 0, this equal to 0, we get 3, and we get negative 7/3 as our other x. All right, so moving on, you are going to have to factor. They're going to be the shortcut method, or maybe the difference of squares, or maybe just a greatest common factor. Those you won't see any long method. They'll be pretty basic. But you do have to factor first, then do the canceling like we did on the previous page. So what that looks like is up here, what can you take out of both of these? You can take out an x, so that leaves you with x minus 4. On the bottom, that's going to be the shortcut method. So what are the factors of negative 8 that add to get negative 2? And we would think about what times what? Oh, 4 and 2. And that would make our 4 negative and our 2 positive. And then we look to see what can cancel now that we've factored everything. It has to be exactly the same. And then we write our final answer of what's left. And then we also want to figure out what would make this undefined. So if we go back to our original, then we look that x cannot equal, and this was negative 4, so it couldn't be equal to 4 or negative 2. Okay. All right, so on the next one, that's going to be a greatest common factor. So what can we take out of both of those? Well, they both have a's, and they both have 4 a's. I can't take any numbers though, so I'm going to take just the 4 a's out. So that leaves me with b minus 2. On the top, or on the bottom here, looks like just a's again. I could take out 3 of them because they both have that. And when I take them out, I have b minus 2 there. So I've got b minus 2 over b minus 2. But then these are also something that I can look to see if I can cancel because they're their own things. Even though they don't match up exactly, a to the 4th over a to the 3rd, I know I can simplify because it's like a times a times a times a over a times a times a. So I can cancel some of those, and or I could use that subtraction since it's the same base. Take the top exponent minus the bottom. So this one is just a. And then what can a not equal? Well, a cannot equal 0 because we set this equal to 0, and this equal to 0, a cannot equal 2. And then the next one. So this one is going to be on the top, taking out the greatest common factor, but on the bottom, those are the difference of squares. So here's kind of your format for that one. It should be x plus 2, no, excuse me, x plus 4 and x minus 4. And then on the top, we can take out a 4x. That leaves me with x minus 4. And then we cancel out anything that matches up. So x minus 4 and x minus 4 are the only things that can cancel. We're left with 4x over x plus 4. And then what x cannot equal, back up here to the original, x cannot equal negative 4 or positive 4. Because we think back to the original of what our x's can equal, because that would give us 0 in our original, which means it can't work. So I want you to try these 3 on your own. They're just like these 3 up here, just a little different order. This first one, difference of squares and shortcut. The middle, shortcut and shortcut. And the last one, greatest common factors. So try those 3 and then check when you're ready. All right, so let's check your answers. So factoring here, we can cancel off the x minus 3's. We're left with x plus 3 over x plus 2. X cannot equal 3 or negative 2. This one, though, we needed to change this to a 6 so it would be able to factor. Sorry for that change. And then we look to see that we have x minus 1's that can cancel. This is an x plus 5. This is an x minus 5, so that's not something that you can cancel. So that's your answer. And x cannot equal positive 5 or positive 1. And then last one here is going to be factoring out a GCF. The only thing we can actually simplify are our coefficients here, 2 over 4 to 1/2. The x squareds can cancel. And then we can not simplify these, so those are left as well. So x cannot equal 0 and x cannot equal -5. Last two things we're going to talk about is multiplying and dividing. And it's actually very similar to what we just have done. I like to just kind of continue this line and then we factor everything and then we start to cancel things on the top and the bottom, no matter what side it's on, to simplify basically. So let's take a look at two examples and then we'll look at division, which is just like multiplication, or we'll change it into multiplication. So first step is to just factor. I like to keep everything again, you can kind of put it over one line if you want to. This is the only thing on this side. You could take out a 2. Over here, this is going to be a difference of squares. So again, you can kind of write everything on the bottom all together, everything on the top kind of all together, if you want to put your parentheses. Now we look for things that match on the top and the bottom, and only one thing on the top that matches up to one thing on the bottom. And that looks like everything that we can cancel. So our final answer is just what's left. So we keep everything that's left. And x cannot equal, and it cannot equal your bottom things. So 3, -3. But on these we don't focus so much as what you can't. It's always just simplifying. But I'm going to go ahead and continue this just so you can see what our x's could not equal for that. So I want you to try this next one on your own. This one is going to be a GCF, so factor out the GCFs of all three of these things, and then difference of squares here, and then just cancel anything that matches on the top and the bottom. All right, so double check your answer here, and it's saying assume all expressions are defined, meaning you don't have to put this. So if you didn't, no worries. We've got it all simplified. This is what we should have left. So the 7y's canceled and the 4x plus 1 canceled. All right, so division is actually very similar to multiplying, and here's why. When we have a fraction on the bottom or try to divide by a fraction, then it's complicated. It's a lot harder to do. So what makes it easier is basically if we kind of rationalize it, but really we don't look at it like that. If we multiply by its reciprocal, that ends up getting rid of what's in the denominator spot, and we end up just multiplying by its reciprocal on the top and kind of skipping all that denominator stuff. So that's basically what we're going to be doing here. It's kind of like rationalizing, but really it just makes it easier. You're just going to change this to multiplication, and then you are going to flip your second fraction and just your second fraction. So it is k squared minus 3k over k plus 1 times k squared minus 1 over k squared minus 4k plus 3. So we've got some simplifying and some factoring to do here on the top. Take out that k, nothing on the bottom there. And then if you want to just continue your parentheses, I kind of like to do that. K plus 1, k minus 1, because it's a difference of squares on the top there. And then on the bottom, shortcut method now, k and the factors of 3 that add to get 4, so 3 and 1. Both negative. And then we look to see what can cancel. So I've got a -3 and a -3. I've got a +1 and a +1. And I have a -1 and a -1. So the only thing left is k. And then go ahead and do this last one on your own. Flip it, factor. This one you can take out a GCF, so it is still shortcut. And then check your answer when you're ready. All right, so as I was working it, I realized I lied. This is a long method because this one doesn't have an x. Sorry about that. So it's first times last 40, factors of 40 that add to get 14. So you're going to group. And again, there's not a whole lot of these, if any, actually on your worksheet. So you should be fine. No long method ones. They should all be pretty quick. But canceling off those things after factoring. And then, oh, we can still take out a 2x here, or a 2. And now I can cancel that one off. And then that's a 3. No, that's not a 3, that's a +2. There it is. That cancels, and it looks like that's it. So we have a 2, x minus 7, x minus 5, and a 2. Oh, so there's that 2 that can cancel there. So it should just be an x minus 7 over x minus 5 for your final answer.